Hello, everyone, and welcome to MOS Live. Ask a Scientist Space Edition. You can tell I've done too many virtual planetariums. Hello, everyone. My name is Janine. My pronouns are she and her, and I'll be your moderator today. I'm really excited to ask some of your questions about space to our stellar panel of museum educators. If you'd like to see captions, you can click on the closed captions button at the bottom of your screen and select show subtitles here in the Zoom meeting. We're so delighted to have all of you here today as our audience, but before we get started, I'm going to let our panelists turn on their cameras and introduce themselves and their favorite Mars mission from the past, so not Perseverance.
Hi everyone, my name is Eric, my pronouns are he, him, and today my favorite Mars mission is the one that started it all, and that was Mariner 4, the very first flyby of Mars, our first up-close look, and that told us the first things we learned about the surface, that it had craters, that it had a giant volcano, so many cool things.
Hi everybody, my name is Sarah, my pronouns are she and her, and my favorite Mars mission is also from the Mariner series, and that was Mariner 9, which was the first spacecraft to orbit Mars, and it did so during a global dust storm, which at the time was not the news they wanted to hear, but in retrospect has taught us a ton about Mars's awesome weather.
Hello, everybody. My name is Talia. I also use she, her pronouns. I apologize if you can hear the vacuuming going on in the unit next door to me. So Eric chose a flyby mission. Sarah chose an orbiter. I'm going to choose something that went down to the surface of Mars. I'm choosing the Opportunity rover, the longest lived so far rover that we've ever had on the surface. It operated for 14 years on the surface of Mars. Not bad for a rover that was only supposed to last 3 months.
Thanks, guys. I'm excited to get us started. For our audience, as the moderator, I'll be fielding your questions, which you could submit through the Q&A tab here in the Zoom meeting. If you're joining us on Facebook or YouTube, unfortunately, I'm unable to see your questions at this time. For now, I'll turn off my camera and try to pick out some questions for these panelists to start answering. All right, so while we're waiting, maybe we can talk a little bit about Perseverance, which touched down last week. So I guess, what is your favorite thing so far that you've learned because of Perseverance or seen?
It's going to be tough to beat. I mean, it's always tough to beat touchdown moment for me. But this one really came when I really needed it. Last week, just watching the landing live, having the live stream of the engineers and the control center, NASA's control center, and being able to watch the just elation and joy on their faces when touchdown was confirmed. And then I also cheered, and I was also really happy. I think it's always good to have some triumph and have things go according to plan. So that was beautiful.
Yeah, the video that has come out in the last few days of the entry, descent, and landing, which was virtually the same as Curiosity in 2012, but we didn't have the cameras recording it. It's just, I knew it was going to happen, and I knew it was going to look good, and it still was just awesome to watch. I watched it over and over again. If you haven't seen it, just go check out Perseverance landing video. It's actual footage instead of usually what we see, which is a computer generated model of what's happening. And right before it actually lowers down the rover itself, the sky crane, which is the rocket that slows down to just the right speed, it does what's called a divert maneuver, which is it knows where it wants to land of all the landscape it saw. And so it pauses. Instead of keeping going towards the planet, it hovers, and then everything starts to move sideways as it picks the perfect landing spot to put the rover down. It was just so cool to watch.
I mean, touchdown is hard to beat, and wow, that video. Wow, that video. So much wow, that video. Accepting those, I have to say, I think one of my favorite things that I've learned since then is that if you take the look at the shots of the parachute that the rover rode down to the surface, it turns out it has a coded message in it. So the Jet Propulsion Laboratory, the group that sort of runs this mission, has a catchphrase or a mantra, if you will, dare mighty things. And it turns out that message is coded in the stripes of the parachute that Perseverance rode down to the surface. So I really enjoyed that little factoid. Dare mighty things.
So cool. We have so many questions coming about Mars and Perseverance now. So first question from Sergio, how long is Perseverance supposed to operate on Mars?
So it's got a primary mission of about a year, a Martian year, which turns out is about 660 or so days, so almost 2 years. But it's likely to last a lot longer because it has a power source that's going to last for a lot longer than that. And it's already there. And so to get the approval and the funding to operate a mission that's already traveled to another planet, it's pretty easy. Curiosity is almost identical to Perseverance. It's a rover that's been on Mars already for 8 years. That mission was only supposed to be a year, and it's gotten a bunch of extensions. So hopefully we will get a decade or more of awesome science from this brand new rover.
We have a question about whether we get to see the pictures from Mars.
Oh, yeah, absolutely. One of the great things about NASA is everything, it releases all the pictures that it takes from all its spacecraft. Some of them are not as cool to look at as Mars, but everything that that Perseverance takes, every picture it takes is going to get released, and it's already been releasing photos. Obviously, that video sequence that we've been talking about, the landing video, that got released. And Eric, I think you actually have. This is a brand new, as of like this afternoon,
So
panorama.
Yeah. So you can see the borders between the individual pictures.
So beautiful.
Stitched together. And you can see the landscape. You can see this perfectly flat landing zone. I mean, of all they talked about the cliffs and the boulders, it really bullseyed this landing on a nice, even flat area. And you can just go and zoom in further and further and further on this image to get these amazing details. And this is the latest one. This is from an hour ago. And right now, scientists are talking to each other. I wouldn't say arguing, but I would say having excited conversations about which of these rocks looks the most interesting to drive over to first.
We have a question from Madden, which is, can sound travel on Mars?
Question. That's a very apt question, because I'm sure you're asking that because you've heard that there is no sound in space. That's true. That's not because things aren't noisy. If we could hear the sun, it would be as loud as like a freight train next to your ear all times. But luckily, there is no medium. There's nothing in space for sound to travel through. There's no air for it to sort of compress and make noises. There is an atmosphere on Mars. It is very thin compared to Earth's atmosphere, but it is still there. So yes, indeed, there is sound on Mars. And although we've sort of hacked our way into hearing some things on Mars using the InSight rover. We were able to use the InSight lander rather. We were able to use a seismometer to kind of hear vibrations on Mars, but Perseverance has microphones. So we are going to be able to hear lots of cool, I mean, it's probably going to be mostly wind and the sound of wheels crunching, but that's going to be really great. And it's going to be from Mars. So yes, there is sound on Mars. And for the first time, we have sent a rover with microphones to help capture some of those sounds.
Thank you. All right. So speaking of the atmosphere on Mars, what kind of gases make it up?
It's almost entirely carbon dioxide. So that is a gas that does occur on Earth, but it's mixed with other gases in our atmosphere. On Mars, it's basically all CO2. There's a few traces of some other stuff. That is a gas that is poisonous for humans to breathe. So we could not breathe the atmosphere on Mars. But one of the very cool things about this rover is it's got a little instrument on it called MOXIE. And MOXIE is an experiment to try and see if we can convert to bring in CO2 from the atmosphere, carbon dioxide from the atmosphere, and turn it into oxygen, actually generate a supply of oxygen, which would be really handy if we ever wanted to, say, send humans to Mars. So one of the things Perseverance is doing is experimenting to see if we can take that toxic Martian air, that carbon dioxide atmosphere, and turn it into breathable air. Not the whole thing, just small amounts.
We have a question from George about what happened to the descent stage that dropped the Perseverance off. Did it crash?
Yep. So the whole entire rocket, if you watched the launch with us back in July, was skyscraper-sized rocket launching a room-sized vehicle all the way to Mars. That room-sized vehicle made it all the way out there, and then slowly it shed parts as it went down. You need your heat shield to slam into the atmosphere at 12,000 miles an hour, to slow all the way down to 1,000 miles an hour. And then when you're done with that, it's dead weight, so you get rid of it. You kind of just drop it on the surface. So from about 36,000 feet up, you can see in that video that we were talking about the heat shield slowly kind of just falling off to the surface. And then the parachutes deploy and you go down to about 200 miles an hour. And then we don't need the parachutes anymore, so they just kind of get tossed off to the side. And then that sky crane was the last part, the rockets firing towards Mars to slow the whole thing down. And then a tether bringing the rover down. Once the rover was safe on the surface, you can't just shut off the sky crane because then it would crush the rover. So it kind of steers itself to the side, blasts away, and it lands. I say lands, but really it crashes into Mars a safe distance away, maybe 100 yards or so. Maybe if we're lucky, they'll decide to go that way for the most interesting science and the best rocks, and we'll be able to get a cool picture of it kind of like laying in a crater on its side. But yeah, anything that isn't the rover on the way there was discarded, and some of it with rockets.
So we have two questions that I'm going to tie together. So Sophia wants to know how many rovers have landed on Mars, and Jacob, who is 5, would like to know, has a rover ever explored a Martian volcano?
So this one is the 5th rover to drive around on Mars. The very first one was a little tiny guy named Sojourner, and it rode down to the surface with the Pathfinder lander. And it was a tiny little thing, and that was in the mid-90s. And then in early 2000s, the twin rovers, Spirit and Opportunity, landed. They both landed in 2004, and they both lasted. Those were, Opportunity was the one I talked about at the beginning. It lasted for 14 years. Spirit lasted for 10 years, something like that. Again, those guys were supposed to last for 3 months. And then in 2012 came Curiosity, who was the sort of real predecessor of Perseverance. So Perseverance is the 5th one. And none of them have landed on a volcano, I have to say. Mostly they like to explore cratery areas. Lots of craters.
We are really interested in volcanic activity on Mars. How recently there has been volcanic activity is a very interesting and important question. And Mars also just has some very cool mountains that are really, really big. Olympus Mons, or Mount Olympus, is the biggest mountain in the solar system that we found so far. So there is lots and lots to explore, but landing on one of those, it's a little tougher.
Curiosity is exploring the base of a mountain.
Yeah, Mount Sharp, as it's called. It has a fancier name, but everyone just calls it Mount Sharp. I can't remember what the fancier name is, but
Aeolus Mons? Is it Aeolus Mons? I don't know.
I think that might be it.
Everybody calls it Mount Sharp. So it is exploring, one of them is exploring the base of a mountain, but that is not a volcano. So no volcanoes yet.
All right, so we have a couple kind of themed questions, like, do you all just leave the heat shield there, and how long has Curiosity, or when is it going to leave Mars? There's some questions about maybe a sample return.
All questions about getting stuff off of Mars.
Yeah, that is the tough part, isn't it? So, it's just the same as Eric's answer. Anything that was dead weight gets jettisoned, and that the heat shield probably took some damage, but yeah, it's just on the Mars surface somewhere. And that is there. I will say there is a lot of thought put into how much we leave behind. Like, they design the missions to be as not wasteful as possible. but at some point, like, you do have to have a heat shield, and you don't want to carry it around with you the whole time. So that's something that they do leave behind. But things don't, nothing has ever launched from the surface of Mars into space. We've never done that. It's hard to get off of a planet and into space. That's why the launch of Perseverance was such a big deal, and it has this huge 50-story rocket that takes it to Mars. We just don't have the resources to build a 50-story rocket on Mars and then launch it. Not yet. So Curiosity has been there for 8 years and is gonna keep being there forever. There is no plan for Curiosity to ever leave Mars, or for that matter, Perseverance or Spirit or Opportunity or Sojourner, Pathfinder, Insight Lander, any of those things. They just stay where they are on Mars. They're not close enough to like say hi to each other, but they are all on the little red planet,
Fun fact that I recently learned. So it's not just the surface where there's old spacecraft that are no longer functioning left around. Sarah, you mentioned that your favorite Mars mission was Mariner 9. I recently learned Mariner 9 is still in orbit. It does not have power, so it's not a functioning spacecraft, but it is still in orbit around Mars, and they expect it to be there until apparently next year is the year they expect it to deorbit and fall to the surface.
I'm going to be, if we could get a picture of the wreckage of Mariner 9 going across the sky. Oh, okay.
I like to think that all this stuff that's littering Mars right now someday will be in a museum on Mars. When we send enough people there to go out and explore and find old discarded heat shields and rovers that ran out of battery because their solar cells wouldn't charge, that someday we'll have enough people there to go get them and put them in a museum and look at them and say, look at this cool thing that came to Mars before anything else.
Imagine finding Opportunity and just like brushing the dust off of the solar panels.
Nope, it hurts. It hurts. It hurts.
There's a comic about that. So Eric, since you were mentioning people going to Mars and being on Mars, we have a couple questions about when do we think the first person will go to Mars?
Keeps changing.
Yeah.
In the 80s, it was the 2000s, and in the 90s, it was the 2010s, and then it became the 2020s. And then lately, it's been sometime in the 2030s has really been the plan. And NASA's human spaceflight program right now is focused on the moon with the Artemis program, sending people back to the moon. They've made good progress on having contracts drawn up for lunar landers and the Gateway space station that's going to orbit the moon. And things are happening. When we'll actually move to Mars and get there, it's getting almost kind of late to say 2030s at this point, because we need to solve so many problems before, and we need to think really hard about when we're going to go. I'm hoping this point still within our lifetimes, but I'm betting not before maybe 2040. It would take a really, really big effort to get there and to make sure that it's safe enough. One of the biggest problems is maybe we could get people there, but it would be so dangerous that we don't want to until we can make it safe. And so I hope 2030s, that would be great. But realistically, let's aim for 2040s.
That sounds fair to me. We have a couple questions about how long is a Martian day?
Such a fun fact, because it's weird. It's like half an hour shorter than an Earth day. It's 23 hours and 30 minutes, I think. Am I right? Or is it half an hour longer? Half an hour longer, 24 hours and like 24 and a half hours.
Yeah.
So it's almost the same length as an Earth day, meaning that Mars rotates on its axis takes about the same amount of time to make a full rotation about its axis as Earth does. But its year, as Eric mentioned, because it's farther away from the sun, it has to travel farther. So it takes like 2 Earth years, but its day, much shorter. And there are no months on Mars. I mean, I guess you could, but it has 2 moons. So that'd be really confusing.
Yeah, it doesn't really work right if you're basing your unit of measurement on 2 things instead of 1. Anyway, we have a couple questions about the little helicopter Ingenuity. When is Perseverance going to launch that?
So I just looked it up before we started, and it has to check out and everything. The rover, it's a kind of secondary test engineering concept type of thing. So Perseverance is going to test all of its systems, do its thing, make sure it's all set to go explore Mars, and then maybe a couple weeks from now, it's going to deploy it. So the best estimate that I saw before I looked it up was somewhere between April 19th and May 19th. So about 60 days from now, and it's a 30-day mission, but pretty quickly after it drops it off, we should get it to test out its systems, make its first flight, land, hopefully beam enough images and videos back to Perseverance that we can get them back here. And if you think the pictures we've seen so far are good, imagine what it will be like to fly along with a drone on the surface of Mars, kind of like buzzing the rover as it goes by. So I would say late spring, hopefully that will happen.
And we do know the helicopter has phoned home. So it's still in Perseverance's belly right now. Perseverance carried it down in its belly, essentially. But it has one thing they weren't sure, it's kind of a delicate thing, this little helicopter. They wanted to make sure it hadn't gotten too shaken up by the launch, the interplanetary cruise, and then that rather rough entry, descent, and landing process, but it has phoned home and it does appear to be in good health.
All right, now we have an interesting question. Since there's no sound in space, how do spaceships or rovers talk to each other?
What a fantastic question. And the answer is the same way that we mostly talk to each other here on Earth, which is in fact using light. Light can travel through space. That's how we know just about everything that we know. Pretty much everything except for like the handful of people who walked on the moon and poked it and said the moon's here. Everything else we know about space, we know because we've gotten light from space. So light travels in space, and that includes signals like radio signals. Radio waves are a type of light. And so we are able to communicate with spacecraft in and around Mars. One of the things that often gets used there are orbiters around Mars besides Mariner 9, which is from 1971. That one's not working anymore, but there's the Mars Express, there's Mars Global Surveyor, MAVEN. There are multiple missions in orbit around Mars, and those can act kind of like relay stations for here to Earth, to get to Earth. So Perseverance doesn't necessarily, anything that lands on Mars doesn't have to have such a huge antenna that it can send signals to Earth. They can just send it up to a spacecraft in orbit like a satellite, and then that sends it over to Earth. That does mean we have to factor in the speed of light to figure out how long it's going to take to hear things, because even light, which is the fastest thing in the universe, does take time to travel. So we are currently about 11 light minutes from Mars. That means it takes about 11 minutes for the signal to travel to Mars. The shortest that we get is like 5 light minutes, and the longest is like 20 light minutes in terms of how big the delay is. So everything that Perseverance does, it does 11 minutes before we hear about it. So, right now, I guess there could be someone standing there like, hey, what's up? And we wouldn't know for 10 minutes, but probably not.
Not someone who breathes oxygen anyway. Lauren wants to know, is it true that one of the rovers was programmed to sing itself happy birthday?
Yeah, that's
Do you
true.
know?
Curiosity for several years would sing itself a song. It's sing itself happy birthday on the anniversary of its landing. This did have like a legitimate reason for the first couple of times to like actually check some rover systems and see how they were doing. And then they just realized they were just doing it really. And it was kind of sad. So they stopped.
Yeah, that brings me back to that comic that everybody should look up about the sad rover that keeps thinking it's going to come home. But one day the people go and see it on Mars.
We'll be so happy.
Yeah. If there is less gravity on Mars, why doesn't the heat shield blow away? How much gravity is there on Mars compared to Earth and or the moon?
Kind of right in between. It's about a third of Earth's gravity. So on the moon, you have 1/6 of Earth's gravity. And so you bounce around kind of like a kangaroo. If you've seen videos of the Apollo astronauts moving around on the surface. And Mars has twice the strength of that gravity, but only a third of ours. So it's right in between, where you wouldn't be walking around like on Earth. You wouldn't be bouncing around like on the moon. Truly, I don't think we know much about the mechanics of how that works, because we've sent rovers, and rovers are slow. The top speed of the Perseverance rover is about 0.1 miles an hour. For our podcast, Pulsar, when I talked to Rich Reber, who is the lead for the mobility systems, all the wheels, all the driving, he said that when OSHA came to test out the rovers to give them their safety check, they said, if you get run over by this rover, it's your own fault. It's so slow. And so basically, you don't have to worry about gravity being different when you're not bouncing all over the place and doing crazy maneuvers. So it'll be interesting to see how 1/3 gravity affects the human body. If we're going to send people there, the heat shield fell from 36,000 feet. So even though gravity is only 1/3, it had a long way to go, and so it probably was mostly obliterated when it hit the surface.
Yeah.
But it'll be interesting to see because we also can't really simulate 1/3 gravity that well. We can simulate weightlessness on the surface of the Earth, or at least above it, by doing those planes that go in the parabolic arcs, and you get that little bit of what feels like 0G, but hard to do 1/3 gravity. So it'll be interesting to see how we adapt to it if we send the first people to Mars.
All right, I think that's
Oh,
all
no.
the questions we have time for today, guys. I know we could keep going on forever, but unfortunately, we do have to wrap it up. So I'll let you guys all say goodbye.
Bye. Thank
everyone.
you for coming.
Thank you all for all of your wonderful questions. I am so sorry we could not get to all of them. There were so many and they were so good. But never fear, we will talk about space again. We have virtual planetarium programs on Tuesdays and Fridays, and lots of other Ask the Scientists as well. So to see what other virtual programs we're offering, you can follow the museum on our social media channels or check out www.mos.org/mos@home. If you enjoyed today's presentation and would like to support more programming like this, please visit engage.mos.org/welcome to support MOS at home. And thank you to everyone who has. Thanks again for participating and joining us today. And we hope we'll see you again soon. Bye.